question 5, I redid sort of 5a. Now I'm doing 5b. And in 5b though, it's this was L'Hopital rule for 1 to infinity. The same way would work for 0 to 0 and infinity to 0. Part B is derivative, and that was a limit, right? Limit goes with L'Hopital. This is derivative, and it's the logarithmic differentiation. Logarithmic differentiation. So how do we do logarithmic differentiation? This is the routine. I like to replace f of x with y because it makes it a lot less messy. So I rewrite the entire thing. Now so that's my first step. Technically it's a 0th step. Step 1, I take the natural log of both sides. And why is that? Again, natural log, always there's a purpose, and the purpose is to basically get rid of the exponents like we did in the other place. Cosine of x. Okay, so then the next step is, okay, so let's do something now. And what is that? That's take the derivative. Derivative of natural log of y is always going to be basically 1 over y, 1 over inside. So what am I doing? Let me write down what I'm doing. I didn't even write it down. Here, take natural log. Here, use the exponent law. Here, take derivative with respect to x. So when you're taking the derivative with respect to x, you end up with 1 over inside times the derivative of inside. Derivative of inside I can show with y prime, or I can write dy dx, whichever is comfortable. It's sort of, we know that that's with respect to x, so I don't have to really write dy dx. And then here I can treat this 1 over x, oh darn, 1 over x as something that multiplied, or I can put it as a quotient rule, or I can use either one is okay. Derivative of the right, I can either use a product rule or I can use a quotient rule. So with product rule, what's the derivative of 1 over x?
Negative x to the power of negative 2.
Which is negative 1 over x squared. And times the second one. Then the first one times derivative of second one. What's the derivative of natural log of cosine of x?
1 over cosine of x times negative sine x.
Exactly. So now that we have that, let's clean it up a little bit. You don't want it too messy, but a little messy is okay. So 5, clean this up, y prime over y is equal to negative 1 over x squared natural log of cosine of x plus minus, see that minus sign, I'm bringing it in front, minus 1 over x, sine of x over cosine of x is tangent of x, right? And then now I want to solve for y prime. What did I want? I wanted the derivative. Now it's time to solve for y prime. So solving for y prime means multiplying by y. Multiplying multiplying the entire thing, big parentheses, by y. Now, if I'm multiplying by y, but then I still have a y on this side, what is y? Y was cosine of x to the power 1/2. So replace that. Don't leave it as y. Make it cosine of x to the power 1x. And so this is solving for y prime. Okay, now I'm answering questions. What's going on? Let me see.
What's
The actual review has exactly what you're supposed to study, basically. The sections that are in the exam.
the format of the exam?
What's that?
What's the format of the exam? Is it just long questions, and how
It's
many?
all long questions. And okay, here's the thing. There are not that many questions, but there are parts to it.
Okay.
So that's the thing. And so I don't know which one to count, the parts or the questions. That's the thing. The questions are not that many, but there are parts to them, basically.
Is it relatively the same length as the last exam?
Yes. No, it's very close. Very close, but you have 10, 20 more minutes? That's it. Very close to that, yes. Okay, so now comparing these two, what is the point? Whoa, there we go. The point was that I want to compare. One was the limit, and I wrote, so in one, I wrote, and Trey, by the way, if you want to ask me about what is going to be on, like what sections, what material is going to be on the exam, I'm going to go after the practice exam. That's what I'm going to do. How about that? Okay. So in here, with the L'Hopital rule, you take the limit and you stick an exponential of ln in here, right? And I don't know where, and then bring the limit to n in between exponential and ln, and that gives you simplify. And when you simplify, then you end up with you change the format and you end up with a L'Hopital rule here. One more step and then L'Hopital rule. So this was the L'Hopital rule, and then that question. And then what happens with the implicit differentiation? With implicit differentiation, you have a definition of y. I'm sorry, not implicit differentiation, logarithmic differentiation. Logarithmic differentiation. You end up with you take the natural log, so you get natural log of something. Then you take you simplify, however that is. Then you take the derivative. You take the derivative, you end up with this, and something like a product rule, like quotient rule, something on the right-hand side, then you solve for y. So the two steps are I compared. One of them has limit, one of them has derivative. In one, if you see if you see a quotient, you take the derivative of top, you divide by derivative of bottom. That's the one that is limit. The other one, you do the quotient rule. If you see a quotient, that's the logarithmic differentiation. And so that makes a difference, basically.
I have a question. When
Mhm.
just looking at an equation that we're taking the derivative of,
Mhm.
how do I know to use just the general derivative rules versus using logarithmic differentiation?
So yes, well, logarithmic differentiation a lot of times we tell you use logarithmic differentiation if the function doesn't look like something with variables to power something with variables. The only one that is obviously logarithmic differentiation is the one. The rest of them, you can do other methods. Most of the rest of them, you can do other methods. But the one that in Calc 1 is very prominent is when you have a function of x that is not constant to power function of x. And that's a logarithmic differentiation. Derivative of this is log diff. Okay. The other one is the L'Hopital rule, or when you put the exponential ln. That one is very much something that you do when you have 1 to the power of infinity form, or 0 to, this is form by the way, 1 to infinity, 0 to infinity, infinity to 0, 0 to 0, sorry, not 0 to infinity, and infinity to 0. Those are the two things, and they look alike a lot. That's why this problem has both of them side by side. So you know. Noah, what was the question? Anything to power 0 is 1, yes. Did that get solved? Thank you, Noah. Yes, okay. And Emmy. Okay, so next part is, what do I do next? Go back to the questions that I didn't do, right? The two